Hello, Jim Wade's here again. Maybe at this point you're tired of seeing me, but hopefully I'm going to offer you some useful technical advice in reference to adjusting the Pintsch Tiefenbach 400 series vital wheel sensors. Now, if you've seen the other training videos and some introductory videos that we've posted here, you will note that we've talked about the 200 series wheel sensor. The 200 series wheel sensor, as discussed in the other video, is a non-vital sensor, and the 400 series sensor is a vital sensor. Okay, they're obviously color-coded differently for a reason. The gray is non-vital, the blue is vital. You cannot interchange these. Even if you try, the systems won't work. But nonetheless, we want you to be aware of the fact that they're two different types of sensors. Now, the architecture and some of the functions are very similar. As a matter of fact, they're somewhat identical. For example, this is a double wheel sensor. Sensor 1, sensor 2, S1, S2. And this one also, S1, S2, sensor 1, sensor 2. The cables are very similar. They both have two pair, and they're color-coded the same, brown, yellow, green, and white. And in that respect, they're very similar. They also both have tuning ports here at the bottom, okay, which are typically held in place with nylon nuts, but we've removed them here just for the sake of illustration. So what we're going to do today is we're going to talk about adjusting the 400 series sensor. So I'm going to set this aside, and we need to mention the fact that the gray sensor operates at 8 volts. This sensor operates at 10 volts. Therefore, any adjustment requires the correct adjustment tool, that is the R58 device. The gray sensor uses the R58/117, and the blue sensor here, the 400, requires the R58/117/1. Okay? Again, 8 volts versus 10 volts. Okay? Important to understand. There's also some other information that is very helpful to know. The 400 series sensor incorporates what's called a reduction plate. The reduction plate is placed between the sensor and the shim, if it's required, in the web of the rail. So sensor, reduction plate, the shim, and the web of the rail. Furthermore, there's two brass ferrules that actually hold this in place, this reduction plate here in place. The 200 series does not use the reduction plate, but it's essential to the functioning of this fail-safe sensor. Okay, so remember, it doesn't install exactly the same way. You have to have the basically the reduction plate, the two brass ferrules, and in some cases a shim, depending on the type of rail. For example, typically 115 RE, 112 RE rail does not require any shims. But for example, a 132 RE or 136 RE likely will. Okay, so keep that in mind. There is an installation guide available from Pintsch North America. Strongly recommend you obtain a copy if you don't have one already. So now what we're going to do is we're going to go ahead and zoom in and let you see things a little bit closer, and we're going to go through the adjustment process. Now, I don't have a cameraman here, and this is maybe a little crude, so if you'd be so kind as to bear with me for a minute while I make some adjustments, and we will go ahead and get this started. Okay, so there we go. Hopefully that'll work. Again, you know, a little bit of a crude video perhaps by modern standards, but likewise, hopefully the technical information is useful. So I'm going to take my R58/117/1, and I'm going to first disconnect the sensor cable from the infrastructure cable. That is, I want to disconnect the axle counting equipment in the relay house or the control cabinet from the sensor. Okay? You can't feed it from the house while utilizing the test device. So I disconnect the field side, and then you'll find that there's 4 alligator clips on this. You connect those to the 4 wires coming out of the sensor. In other words, you match brown, yellow, green, and white. There's 2 pair, brown and yellow for S1, green and white for S2. Likewise, this has a brown and yellow pair for S1 and a green and white pair for S2. So you just match them together, and then this now simulates the front end or the switching amplifier module of the axle counting system. Okay, so again, disconnect the sensor from the field side, connect this device here, the R58/117/1 to the sensor cable, and you're ready to adjust the sensor. Okay, so what we're going to do is we're going to power this up. Okay, and you'll see here that there's some voltage on it. The open voltage across each pair will be about 10 volts. But again, we're generating a field here. It's coupling into the head of the rail. There's damping occurring, and we're measuring that voltage across that pair, which right now is around 6.2 volts roughly, okay, on that analog scale. So I'm going to take this device next, and you can see that this is graduated in millimeters. It might be a little hard to see. Hopefully you can see it, but you can adjust this until this piece here lines up with 45 millimeters. Okay, so I'm going to line that up with approximately 45 millimeters. Okay, let's make sure you guys can see it somewhat in there. Okay, and then I'm going to take this groove over here and place it over this little ridge at the center of the wheel sensor. So he's going to line up on that ridge, and I'm going to push him in. Okay, and then I'm going to line this side of it. Okay, let's call it the rail side of the SSPV1 plate, kind of vertically with the gauge side of the head. Okay, so on this sensor, if you can see it, it lines up. I want to line them up basically with this. I don't want it to touch the rail, however. Okay, I just want to line it up there, and then so I'm going to put this guy like this. Okay, now you can see both lights have illuminated. So if they're already on and you want to make sure it's adjusted properly, you can take this EW1 tool. You can basically insert it in the tuning port. You push upward against a spring-loaded cam. That unlocks the tuning port, allowing you to adjust the sensor. You have to make sure you push up to release that cam. As explained in the 200 series video, it exists to lock that tuning port in place so that vibration from passing on-track equipment doesn't slowly over time knock the sensor out of adjustment. So push up against the spring. We can back this guy off until the red light turns off, the little red LED. I'm going to turn this until it just turns on. Okay, and maybe back it off again, bring it up very slowly. Okay, S1 is adjusted. Okay, now I'm going to do S2. Okay, so again, I want to get this in the little tuning port. I'm going to back this off. Okay, you can see the meter move here. Okay, so what I'm doing is I'm bringing this up to a turn-on threshold. So we're adjusting S2. You can see the voltage rise. Okay, and there, it just turned on. Okay, and if you look over here at the meter, it reads about 8.6 roughly volts. Okay, that's the turn-on threshold that I'm adjusting to. Same thing over here. If you look, it's 2.5 volts per division. So you can see there's 7.5, a little over 8 volts. Okay, so they're both now adjusted correctly, and then I can simply take this guy off, and I'm good to go. Now, a couple of things to note. When there's no wheel flange present, voltages across these pairs will vary a little bit depending on the characteristics of the rail, the sensor, and so on. But typically, it'll be between 5.5 and 6.5 volts in that range. As a wheel flange passes over, the voltage will rise to approximately the full 10 volts. So watch. Okay, you can see here the voltage has risen to approximately 10 volts or 9.8, somewhere in that range. Okay, so now watch as I pass this over, watch the oscilloscope. You can see the impulses being created. Okay, and you'll see that this analog impulse has a fairly sharp rising and trailing edge. Okay, that's the sign of a well-made, well-designed wheel sensor. This particular analog impulse is very easy to signal process, and it's also very consistent for things like speed measurement, say in a constant warning time system or in a yard application. Very consistent speed measurements can be obtained from that type of analog impulse. So again, generally speaking, no wheel flange is present. You can see we're somewhere there in the 6-volt range, right? And if I place this on top, it's going to rise to close to the full 10 volts. Now, one other thing to note, what makes the sensor vital amongst characteristics within the evaluation or axle counting equipment itself is the fact that it incorporates off-rail detection. So for example, let's imagine the sensor is bent down or damaged by passing on-track equipment. Okay, so he's displaced from the web of the rail for some reason. We wouldn't want, for example, the sensor to be laying on the ground or damaged such that on-track equipment could penetrate a vital axle counting circuit and perhaps we have an activation failure or the signal doesn't respond appropriately. So in the case that this wheel sensor is displaced from the rail, you'll note the voltage has dropped below 4 volts. I think it looks like about 3.8 or so, 3.9. This will be sensed by the axle counting system, and the axle counting system will fail safe. That is, it will default to the most restrictive signal condition. For example, it will activate the grade crossing or turn a wayside signal red or some such thing, right? It'll treat it as an occupied track circuit until which time the signal maintainer identifies the problem and corrects it. So again, normally no wheel flange present. It's going to be 5.5 to 6.5 volts. When a wheel flange is atop the sensor, usually it rises close to 9.8 to 10 volt range. And then if there's an off-rail condition, you'll see across the pair this low voltage here. Okay, and again, that's a tool that you can use for troubleshooting in the event that you are investigating a problem with a Pintsch Tiefenbach axle counting system. Now I've gone ahead and resecured it to the rail, and of course I'll tighten it down. And again, you can see that we've returned to the normal standby voltage. So just to review, again, if you have to replace a sensor, make sure you understand the importance of the reduction plate, and if necessary, the shims, and the brass ferrules, which aren't visible in the video, but they affix the shims and the reduction plate to the web, okay? And obviously, make sure they're in the correct order. Make sure you have the correct R58 device. You need the R58/117/1. And then, of course, you need to have either the EW1 tool or the little special adjustment ferrule that is provided free of charge with the sensor. Okay. Then what we want to do is we want to make sure this is set to usually 45 millimeters, although there are some systems that may require, for example, 43.5 or 47, but generally the default's 45. And then, of course, make sure you apply this correctly on top of the sensor and then adjust it accordingly, right? So that's the trick. When you're done, make sure that you put the little nylon nuts back on. I happen not to have one with me for the video, but I'll take one off of one of these other wheel sensors here. You basically take these and resecure them on the bottom. And what these do is they prevent debris from accumulating, say, under the sensor and pushing up on these tuning ports and releasing that cam, right? So, you theoretically, say, you can have lots of taconite or other debris, say, in an iron ore mine that would collect underneath and push these up. So the nylon nut prevents that, but there's two. There should be one on each one. I hope that answers some questions. If you have questions, you can call Pintsch North America. The telephone number is 618-993-8513. And we'd like to thank you for taking the time to look at this video. And hopefully this answers some questions about how we adjust the Vital 400 series sensors used in Pintsch Tiefenbach axle counting systems. Thank you very much for your time, and have a good day.